A highly engineered system can survive immense external pressure, but a single fracture at its foundation will bring the entire structure down. Integrating Salesforce with external APIs requires a clear baseline. Developers must write Apex logic to construct and send outbound HTTP requests to those external servers. The most critical vulnerability in this process occurs immediately during construction. Developers frequently store the required authentication secrets and physical endpoint URLs directly inside that Apex codebase. Hard-coding API keys and authorization headers leave sensitive data exposed as plaintext. Anyone with basic read access to the application logic can instantly extract those credentials. Even if the system avoids a security breach, hard-coding guarantees an operational bottleneck. When an external provider rotates their passwords, the development team must manually locate the exact string in the code, rewrite it, run new unit tests, and execute a full deployment just to restore the connection. Salesforce engineered a native countermeasure to eliminate this exact vulnerability: named credentials. A named credential acts as an architectural abstraction layer. It deliberately separates the execution of the code from the security configuration. By enforcing a strict separation of concerns, the management of credentials moves entirely out of the developer's Apex logic and into the platform's secure metadata environment. Treating authentication as a modular configuration rather than static code prevents severe plain-text security breaches and eliminates the friction of emergency code deployments. To understand how this abstraction operates, we look at the Apex execution environment. Building an HTTP request requires defining a method, setting a destination, and attaching secure headers. Named credentials connect to that Apex environment through a highly specific alias prefix, the callout syntax. In this side-by-side comparison, legacy logic on the left relies on physical URLs and explicit headers. On the right, the callout alias replaces both. The string myExternalAPI routes the request away from execution code into an isolated metadata layer. This routing architecture creates centralized management. When an external provider updates their base URL or requires a password rotation, the administrator updates the metadata configuration. The Apex code block remains completely untouched. Because the actual application logic has not changed, the update completely bypasses the standard code redeployment pipeline. Modifying that single metadata record scales instantly across the entire Salesforce org. Every single Apex class that references that specific callout alias is automatically routing to the new, secure endpoint. Abstracting endpoint details into centralized metadata takes a highly technical, risk-prone development task and reduces it to a secure administrative update. That routing mechanism handles static data effortlessly, but enterprise integrations frequently rely on complex, stateful authentication protocols, specifically OAuth 2.0. Historically, managing OAuth required hundreds of lines of manual Apex logic dedicated solely to checking token expiration limits, parsing error codes, and requesting new access tokens. In this sequence diagram of a standard integration, we see the initial point of failure. A transaction fires, but the session token has naturally expired mid-flight, bouncing back a 401 unauthorized error to the server. But when routing through a named credential, Salesforce assumes protocol management. The gateway natively automates OAuth and intercepts the 401 error before it ever reaches back to the Apex code. The platform automatically negotiates with the auth server, retrieves a fresh token, and injects it into the waiting packet. This newly authenticated request is then released to the final endpoint. Throughout this entire background negotiation, the original Apex logic remains completely agnostic. As far as the code is concerned, the HTTP request succeeded on the first attempt. Offloading stateful protocol automation directly to the platform drastically reduces codebase bloat and eliminates massive vectors for human error inherent in custom authentication logic. Beyond individual request management, enterprise architecture requires moving logic through strict boundaries, from sandbox testing environments into live production orgs. Legacy deployment pipelines introduce a severe risk known as the redeployment trap. Developers must manually track and alter physical endpoint URLs in the code as a feature is promoted from a test server to a live server. Named credentials solve this through environment portability. We can see the deployment pipeline divided here into a sandbox testing environment on the left and a live production org on the right. Because credentials are abstracted, the identical block of Apex code deploys across all environments without modification. In the sandbox, local metadata points to a safe staging API. The production org contains a named credential sharing the exact same naming convention, securely pre-configured to point to the live customer data endpoint. Pushing the Apex code between these environments requires zero manual adjustments to URLs, headers, or security parameters. If a block of code executes successfully against the sandbox configuration, that exact same text file will execute with identical mechanical predictability in production. Environment portability removes the risk of human oversight during deployment, ensuring a secure and frictionless continuous integration pipeline. At its core, enterprise software fundamentally relies on overlapping, highly complex systems acting in perfect, uninterrupted synchronization every single day. Integrating external systems naturally introduces risk. However, that risk does not stem from the API itself. It stems entirely from how developers choose to manage their secrets. This matrix details 4 named credential advantages. Security. Secrets are completely eliminated from the codebase. Centralized management. Endpoint updates require 0 code deployments. Protocol support. The platform natively automates complex authentication like OAuth. Environment portability. Code moves seamlessly to production using identical syntax. Because these 4 advantages intersect to eliminate both security vulnerabilities and deployment bottlenecks, Salesforce explicitly dictates named credentials as the definitive best practice for outbound authentication. Utilizing the callout: syntax enforces a strict architectural mandate. It demands enterprise-grade security and scalable resilience across every external connection in the Salesforce platform.